Welcome to Easy Math TV. This is another video in which we're going to be creating a frequency distribution in StatCrunch. And by the time you're done with this homework in Chapter 2, you should be fairly familiar with things like frequency tables and histograms in StatCrunch, and that's a good solid basis to start our next couple of units in statistics. So this time we're going to be constructing a frequency table of continuous data. And the first time I submitted the problem, and I actually was trying to record the video before, and to my surprise, I actually got the problem wrong because I was making an assumption that these intervals here are in like bracket on the left and parenthesis on the right, but they're not. So I'm going to have to show you how to do this using StatCrunch, okay? If I click on this icon, we actually see our data is listed here. Those are our numbers, so we can actually go ahead and open it in StatCrunch. There's our data. These are magnitudes of earthquakes. So stat table frequency. Select the column, select frequency, and we could even look at relative frequencies if you want, but we're not. We do want to bin the numbers, and we do want to start our first bin at 1.0, and our bin width is 0.5. So that's what's stated in the problem. The problem states to start at 1.0 and have a bin width of 0.5. And I've got everything else selected, so let's just hit compute. So I'm going to want to write this stuff down on a piece of paper because I can't have both windows open at the same time. I have to show you what to do with this. Because notice that in StatCrunch, it actually specifies that the first interval includes 1 and goes up as close as you possibly can to 1.5, but there's a parenthesis there. And since we don't have that ability to put a parenthesis in our homework problem, we're going to have to calculate the upper limits by hand. So I want to show you how to do that. How do we calculate our upper limits for each of these bins by hand? But there's our frequencies. So copy down your 2, your 10, your 37, the 25, the 17, the 6, the 2, and the 1. So I want to make sure I have all of that copied, and I do. So so it's just a matter of figuring out what that upper limit is for each bin, okay? So I'm going to show you how to actually do that. All right, now let's look at these numbers again. So these numbers are out to how many decimal places? So basically 2.889 is 3 decimal places. So I want you to think about that first bin from 1 up to 1.5, but not including 1.5. So what would the nearest number on here be to that? So what I do is I get my calculator and I start with that 1.5, and I'm like, what number just under that would be included on this list? So I have to subtract 0.001, which is basically, that's the number of decimal places that I have in any number, but I want to subtract 0.001 from that 1.5. And let's calculate that. That's equal to what? So the largest value on that list of earthquake magnitudes, the largest value that would fit in my first bin would end with 1.499. Okay, 1.499. So I'm going to move that off to the side. So instead of 1.0 to 1.5, I'm going to put 1.499 there. My second bin, however, the starting values are all going to be exactly what we expect. So this is going to be 1.5. This is going to be 2.0. This is going to be a 2.5. These are all the lower limits. The lower limits are exactly what you expect them to be. .0 and then 4.5. But my upper limits, instead of the number that is given to us, we have to subtract 0.001 from it. So let's do this one more time. The second class in my frequency table was from 1.5 up to 2, but not including 2. So I'm going to start with the 2, and I'm going to subtract 0.001, because that's how many decimal places my data has in it. Calculate that, and that is 1.999. So we can expect our upper limits now to alternate from a 0.499 to a 0.999 type thing. So 2.0 is going to go, our next class is going to start at 2.0 and go to 2.499 now, because that's just under 2.5. And then 2.5 to 3 to, sorry, not 3, but 2.999. And then 3, instead of going up from 3, we don't want to stop at 3.5. We want to stop at 3.499. Wait, did I have too many 9s there? 3.499. Yeah, there we go. And then 3.5, instead of stopping at 4, we're going to stop at 3.999. And then for the next class, 4 to 4.499. And then 4.5 to 4.999. Got that? So every one of those upper class value, like if you need to just take your time and calculate them all, using your calculator, take that upper class limit, say it was a 3, and subtract 0.001 from it. And that will tell you what your upper class limit should be. Instead of a 3, it's going to be 2.999, okay? So you can just do that with all of your upper class limits that were from StatCrunch. And now I'm just going to type in all my frequencies. I have a frequency of 2 and then a 10. I'm copying this down from the one that I just wrote it down, because I can't have 2 windows open at the same time when I'm doing my video. So I'm really hoping that this will be correct, because I don't want to have to record the video again. So those are all my answers. I'm going to hit check answer. Oh boy, I did get it right this time. Awesome. So let's answer the next question. Does the frequency distribution appear to be a normal distribution? So to answer that question, I really kind of need to be back in StatCrunch again. So let's view these again. The frequency table only helps us a little bit in determining that. So like I would say that that's an incomplete picture. So we're just going to go ahead and do this again. And I do want to look at our frequency table. So there's our frequency table. But in addition to that, I want to make a histogram. So I'm going to go to the graph menu and I'm going to choose histogram. And it's very similar to a frequency table, but we're going to actually see columns for each of our frequencies. So our bins are going to start at 1.0 and then a bin width of 0.5. And I want to look at the value above each bar as well. So let's hit compute. Okay. This just gives us a little better picture. Okay. Now, so you can say that your data is approximately normal if the tallest of the rectangles is as close to the middle as you possibly can be. So so this is kind of open to interpretation, but it looks to me as though there is a little bit of skewness in our data because the tallest rectangle, all of our numbers are between 1 and 5. And I would expect this, at least this rectangle right here, should be the tallest, or it should be distributed between these two. These two should be our tallest two rectangles. And they're not. The tallest one is to the left of the middle and slightly to the left. So I think that there's skewness in this data. I could be wrong about that, but I'm going to clear all of our selections. Let's see what the options are and see if we can answer the question. So the frequency distribution, and I'm going to say is likely not a normal distribution because the frequencies here, this is going to be, yeah, this is what I'm looking for. I'm looking for something that starts low, increases and then decreases, but it's not symmetric. Not symmetric. And let's check our answer there. Yeah, so that is correct. So in order for something to be roughly normally distributed, you would need the largest values to be very much in the middle of your data. And then the smaller ones are to the left and to the right. So like, subscribe, comment down below. If you're enjoying these videos, if you find them helpful in your study of statistics, share them with other people, and I'll see you in the next video.